Section 1.4, Integers and Absolute Value. Integers are a set of numbers that consist of whole numbers and their opposites. We already know that the whole numbers on a number line are the value of 0 and all the numbers to the right, or positive values. There are no fractions or decimals. Therefore, 0, 1, 2, 3, 4, and 5, and so on. We now have the integers that include those sets of numbers and all the negative values. And that would be a -1, -2, -3, -4, -5, and so on. Again, there are no fractions or decimals. We also know the farther we get away from 0 on the positive end, the bigger the numbers are, the bigger the values get. On the contrary, the farther I get away on the negative end from 0, that means that the numbers are getting smaller. The farther to the left I get away from 0, the smaller the value gets. On the contrary, to the right, the bigger the number is, means it's the farther away from 0. And you can see I have my negative numbers, my positive numbers, and 0. Opposites are two numbers that are the same distance from 0 on the number line, but they have different signs. So for example, if I have a positive 5, its opposite is a -5. A -5 and a positive 5 are the same units away from 0. Therefore, the opposite of a positive 5 is a -5. Similarly, the opposite of a -2 is a positive 2. They're both 2 units away from 0. And finally, we have the absolute value. A number's distance from 0 is the absolute value. The absolute value of a number is always represented as a positive value. Here's an example. The absolute value of 5 is written as this symbol. This symbol here and here represent the calling of this number as the absolute value of 5. And that's how that's represented. To simplify that, the absolute value of 5 is 5. It's 5 units away from 0, and it's always represented as a positive number. Another one would be the absolute value of a -7. The absolute value of a -7 is 7. And when I perform the operation or take the absolute value of a number, the symbols go away. The absolute value of 5 is 5. The absolute value of a -7 is 7. It's 7 units away from 0. Write a number to represent each quantity. Number 1, an increase of 5 pounds. That would be a positive 5. I could put a plus sign here to represent that it's positive, but that's what we're trying to do, is determine, is this value a positive value or a negative value? An increase of 5 pounds, a positive 5. 10 seconds until takeoff. That's a negative number. We're waiting 10 seconds until takeoff. A debt of $5. I owe $5. So I'm $5 to the negative end. 50 feet deep in the ocean. If I talk about sea level, I'm below sea level. That would be a -50 feet. And number 5, an apple dropped 8 feet to the ground. That's a -8 feet. Here I want to write the number represented by each point on the number line. Therefore, number 1, I want the point represented in the number line for A. A would be 1, 2, a positive 2. Number 2, B. Here they want B, which is -1, -2, -3, -4, -5, -6, -7, -8, -9. 3, C, that would be a -6. And finally, 4 is D, which would be 1, 2, 3, 4, 5, 6, 7. In this example, they want me to graph each set of numbers on a number line, then order the numbers from least to greatest. First, 5. Next, 8. Zero. -4, and finally -8. And they want me to order these from smallest to largest. I just go from left to right on my number line. From left to right, -8, -4, 0, 5, and finally 8. The next example, use the number line to find the absolute value of the integer in the given pair. Here I'm given 5 and -5. So I have -5 and I have 5. The absolute value is going to be the distance from 0. And that, of course, is going to be 5 units. The absolute value of 5 and -5, they are both 5, since they're both 5 units from 0. Next, this is the procedure to simplify absolute value expressions. Again, I want to copy the problem. 2, simplify the expression without the absolute value symbols. Simplify each expression. The absolute value of 4 is 4. I want to copy this problem and then simplify. Number 2, the absolute value of a -12 is 12. Number 3, the absolute value of a -23. And if that was in the book, I would write it down on my paper like this, with symbols. The absolute value of a -23 is 23. And notice when I simplify this, the absolute value symbols go away. Number 4, the negative absolute value of 35. Since this is on the outside of my symbol, I have to bring that down. So I bring the negative down, and then I take the absolute value of 35. The absolute value of 35 is a positive 35. But that negative now makes that a -35. Number 5, I have an absolute value symbol of a -18, but there's a negative out front. I bring that negative down, then take the absolute value of a -18, which is 18. Well, my solution is a -18. In this example, write a quantity each integer could represent. In other words, make up a story about what a -20 could represent. For example, I could say 20 feet below the surface of the ocean. On the next one, I have a positive 14. I could actually say this could be a 14-foot high tree. In this example, compare using greater than, less than, equal to complete each statement. Again, I want you to copy this problem down, and I want you to simplify before putting in any of these inequalities or equal to symbols. So copy this problem down and then perform the operation. The absolute value of a -15 is 15. The absolute value of 17 is 17. 15 is less than 17. Our next one, the absolute value of 22 compared to the absolute value of a -34. I know this seems easy, but I want you to perform the task that I asked you to. Copy the problem and then simplify. The absolute value of 22 is 22. The absolute value of a -34 is 34. Here, 22 is less than 34. Therefore, the absolute value of 22 is less than the absolute value of a -34. The absolute value of a -32 is 32. The absolute value of a -24 is 24. 32 is greater than 24, therefore, the absolute value of a -32 is greater than the absolute value of a -24. And the last one, the absolute value of a -18 is 18. The absolute value of 35 is 35. And we know 18 is less than 35, therefore, the absolute value of a -18 is less than the absolute value of 35.